Okay, problem 4. Find the parametric equations for the line of the intersection of the following planes. Okay, so you have two planes. My drawing could be bad. Okay, let me do this. Okay, one plane is like horizontal, and another plane is like this vertical plane. Okay. Okay, so you can see there's an interaction, right? You can see there's an interaction. So first, find the line, right? Find the equation for the line of the interaction. So to get the equation for a line, we said we need two things, right? First, we need a random point on the line. So first, these two planes, their equations are given. This is the equation, let's say this is the equation of the horizontal plane. This is the equation of the vertical plane. Okay, first you need to find a point, right, on their intersection. So you need to find an XYZ that satisfies these two equations at the same time. Okay, you don't have to solve it systematically. You can quickly observe that if y and z are both 0, x is 1, right? It's a point satisfying both equations. So you know that 1, 0, 0 must be on the plane, okay? So now you found a point, sorry, 1, 0, 0 must be on the line. You found a point on the line. Okay, then you need to find the direction of the line. Okay, what's the direction of the line? All right, now it's a bit tricky, right? So you have to be creative because this line, right, is on both planes. So you can see this line, this red line, it's on both planes. And these two planes, they both have a normal vector, right? Let's say they both have a normal vector. So this red line, it's perpendicular to both normal vectors. Okay, so let's call it L. So L is perpendicular to N1 and L is perpendicular to N2. Okay, so, right, remember when you do the cross product, right, when you do the cross product gives you a new vector that is perpendicular to both. Okay, so to get the direction vector, you can just use N1 cross N2. Okay, next question, what is N1, what is N2? Again, N1 is easy. It's the coefficients of x, y, and z for the first plane, right? So N1 is just 1, 1, 1. N2 is the coefficients of x, y, and z. N2 is just 1, 2, 2. Okay, so the direction vector is 1, 1, 1 cross 1, 2, 2. Okay, let's just write it down. So it's 1, 1, 2, 2, negative 1, 1, 1, 2, and positive 1, 1, 1, 2. Okay. So this part is the product of this minus the product of this. Okay, it's 2 minus 2, it's 0. Okay, this part is the product of this minus the product of this. So it's 2 minus 1. It's with a negative sign. It's negative 1. Here it's 2 minus 1. It's 1. Okay. So this is the direction of the line, right? That's why the line, right? The equation describing this line is a point on the line plus t times the direction of the line. And t is a real number. Okay, and t is a real number. And the parametric equation, you just need to do one extra step. Right? X is 1, Y is negative t, z is positive t, and t is any real number. Okay. This is a line. And also, what is the angle between these two planes? Okay. For this part, you should be a bit creative. The angle between the two planes right? The angle between two planes is equal to the angle between two normal vector, right? So it's equal to the angle between n1 and n2. Okay, so to get the angle between n1 and n2, you just need to use the dot product formula, right? Cosine theta is n1 dot n2 over length of n1, length of n2. Okay, so n1, n2 is 111, 122. Okay, it's 111 dot product 122 over the length of n1 is right, 1 square plus 1 square plus 1 square times here is 1 square plus 2 square plus 2 square. Okay, so the top is 1 times 1 plus 1 times 2 plus 1 times 2. The bottom is square root of 3 times square root of 9. Okay. So the result is 5 over 3 square root of 3. Okay, then you can get theta with your calculator. Theta is around 0.2756 radian. Okay, this is the angle between two planes.